this video is going to go through the solution to the activity that you did in Savas, which was for the 1-6 Explore and Reason. So this one, it gives you a graph, and it says that the two lines intersect at one point. Part A is asking, what are the approximate coordinates of the point of intersection? So you're going to look at these two lines, and we're going to guess where they intersect. Well, it looks like for the X, it's a little bit past 3. So let's call that maybe like 3.3. And then for the Y, it's up beyond the 4, but not quite to the 5. So maybe let's try 4.7. So for part A, again, you're just guessing at where the coordinates are. And you might have a different answer than what I have, but you should have something that is very similar to what I have. Like you should have something that's 3 point something and 4 point something, just because of where the point is. So part B, how could you verify whether the coordinates you estimated are in fact the solution, and is the point the solution to the equations of both lines? So in order to do that, we could actually come up with the equation for the blue line and for the red line. So if we look at the blue line first, the y-intercept of the blue line is 3. My slope is up 1 and over 2. So for the blue line, I'm going to have y equals 1/2 x plus 3. So that's going to be for the blue line. For the red line, we might need to do a little bit more work for this because I can't actually see where the y-intercept is. However, I know my slope is up 1, 2, 3 and over 1. So if I keep going down 3 and over 1, if I start at this point, I'd go down 1, 2, 3 and over 1. That puts me down at -2. And then down another 3 and over another 1 would put me down at -5. So I'd have y equals, again, the slope is 3x and then -5. And that's going to be for the red line. So in order to test whether this is actually a solution, I could go through and plug both of these values in and see if the two sides are equal. So I could see if, for example, for the blue equation, if I take half of 3.3 and then add 3, I should get 4.7. Well, if I plug into the blue like that, and I'm going to pull out my calculator here, half of 3.3 is 1.65 plus 3. I get 4.65. Let's see here. So if I plug it into there, again, my y was 4.7. I get 4.7 equals 4.65. And that is definitely not true. That's not something that actually works out. So that is something I would have to cross out because that doesn't actually work there. If I plug into the other one, again, I'd have 4.7 equals, and I do 3 times my 3.3. So 3 times 3.3 is going to be 9.9 minus 5. That gives me 4.9. So again, that one does not work either. I know I'm close, but I'm not actually where I'm supposed to be. So the question says, how could you verify? You could verify by plugging in. And is the point a solution? No, not a solution. So this is not, in fact, a solution to what we have here. And it says, use your result to refine your approximation and try again. Can you find a point of intersection this way? So maybe, I don't know, maybe the 3.3 is too big and I want to change it to, say, a 3.2 and maybe keep the 4.7. I can try that. It looks like I'm half away on this, so by making it a little bit smaller, that might actually work out, or it could be 3.4. So you could go through and do this by testing, by changing your points to the 3.2, the 4.7. You could adjust the decimal points a little bit up or a little bit down, maybe make this a 4.8. And it says, is there a more efficient way? The more efficient way is something that we are going to be looking at in our section for 1.6. So is there a more efficient way to make this work out? That is going to be the key behind everything that we have here. And I think I actually have the solutions on the next page. You can see the solution is actually 3.2, 4.6. So both of my answers were just a little bit too high. We can verify by substitution, and yes, solving algebraically might be more efficient. So those were the answers that they expected you to have. Again, you would get credit as long as you tried some type of method or you put in some type of answer for that. And that will conclude this first video, because this is just going through the solution to the Explore and Reason. Be sure you watch the 1-6 video in full so you can see how to actually solve these algebraically. And as always, contact me if you have any questions.